I do this just to make sure that they are not aliens. They are all your friends. Okay? Feel free to ask them questions later on, not right now. Okay, the next one, please.
I thank Mr. Robert West for his wonderful session on Introduction to Toxicology. Next, I request Dr. Maithili ma'am to introduce Mr. Stephen Bennett for his next session. Thank you. Welcome, ma'am.
Thank you, ma'am. Mr. Stephen Bennett has been an experienced consultant in safety and health management for over 40 years, providing leadership to Fortune 1000 companies. He delivers risk management solutions in areas such as human and system performance, disability management, workers' compensation, safety and health, ergonomics, behavioral management, and risk information. Mr. Bennett has developed client solutions for workers' compensation to reduce injuries and related costs, including a suite of diagnostic gap tools. His expertise includes loss prevention, regulatory management, industrial hygiene, workers' compensation, return to work, and employee or operational management or executive training. His consulting work often involves the development and implementation of global solutions.
Good afternoon. The first thing I'd like to do real quickly is say that my career is in the twilight days. I won't be working for much longer. I've had a great career. I've had opportunities to have success, to see clients have tremendous success from the work that we've done together. Experience as you go through your career, have success, help organizations succeed, and have a wonderful career. So I look forward to that, and I wish you the best of luck as you move forward. My topic for today is hazardous chemicals and worker safety. What I'd like to do is cover just a couple of topics: hazard controls, some best management practices, a real quick discussion on industrial hygiene, touch on HazCom, and then talk about hazardous materials and response. So, really a hazardous crisis response is what it will actually be. I won't spend too much time because I know we've cut down, but India has gone through processes, and as the government has correctly so decided that worker safety is important and that rules need to be in place to make certain that employees are protected. And I'm not going to read through all this, but you have your statutes in place that ensure that workers have a safe work environment. What if I step away from that a little farther? Your objectives: preventing fatalities, injuries, and so forth, reducing the cost of workplace injuries. And again, this is all in your statutes. I don't want to repeat a lot of that at this point in time. What I do want to talk about very quickly is the fact that when we look on an annual basis across the globe, we have over 300,000 fatalities from occupational accidents. That's from the ILO, and we have nearly 3 million fatalities from disease, and most of those diseases occur from chemical exposure. And that's part of the reason we're here to talk about these types of issues. One of the issues you've got that I've seen in my career, small businesses quite often lack the knowledge and expertise of how to deal with those issues. And a lot of what I was able to do during my career is work with small corporations. I work with large global multinationals, but I also work with small organizations and help them put processes in place to protect their workers. The other part of the global company side is that for years, I will tell you, we had a difficult time getting large corporations to take safety processes and apply them across the globe. The good thing that's happened is reputation risk, brand risk, has become very important to organizations, and taking care of workers, I think the safety level has risen all across the globe for that one reason. It's a wrong reason, but we'll take it any way it happens. We talked about hazard control. We need to have steps in place to protect our workers. We need a written workplace plan in place that talks about our hazards and how we're going to go through those processes to protect our employees. We need to have training. And we'll talk about that a little more difficult. And as I come up multiple times, this first line, risk assessment, will be a common theme. Risk assessment is a core function of a safety and environmental side. I'm not the environmentalist here, but being able to understand how significant the risk is in my work environment is going to be an important part. I talked about preparing for emergencies in the last couple of slides to talk about that. The other thing I reference on this slide is that what some organizations do to help reinforce safety within their organization to everyone. We have clients that start every meeting with a safety message. And I don't care if it's a finance meeting that has nothing to do with safety. They will start their meetings off with a short 1 to 2 minute, it can be very brief, but they'll talk about safety to start things off because they want, within the culture of the organization, they want people to be concerned and thinking about the safety side of their business. Back to my topic, when we talk about controlling hazards in the workplace, a typical process that we look at is the hierarchy of controls. The best, which is the top line, the blue line is elimination, and I'm going to talk about each one of these. The least effective is personal protective equipment. We'll actually have a topic on that. They're all used, they're all valid, but when we're looking at a particular hazard, we've done risk assessment, we don't like our exposure to chemicals in a particular process. This is the thought process, the logic that we would apply to try to figure out how do I mitigate a risk in the work environment. Elimination, substitution, engineering controls, administrative controls, and then ultimately personal protective equipment. Elimination is the easiest of the three. In essence, I take whatever the hazard was and it's no longer in the work environment. I take a toxic chemical and replace it, although from Bob's comments just a second ago, everything actually has some toxicity to it, but in relative terms, it has no toxicity. I've got an unnecessary blade on a piece of equipment, I remove that blade. I've got some equipment that's faulty, we discontinue using that piece of equipment. We eliminate the particular hazard because we've taken it out of the work environment. Substitution, I take a solvent-based paint, which has significant hazards to it at times, and replace it with a water-based paint. Water-based paints still have toxicity, they still have hazards to the workplace, but they are significantly less. I've mitigated my risk. I no longer have eliminated it, but I've reduced it in some fashion. Engineering controls. We have a couple of engineering students out here, I heard. I was an electrical engineer when I went to school, so yay for us, by the way. How do I go through the engineering control side of this? Initial design specs. Reformulation, which kind of looks like our substitution concept. Reduction of the risk by installing barriers. When we look at an industrial environment and I have a moving piece of machinery, quite often we put a guard around that. The intent of the guard is to, let me get away from that mic a little bit, or the speaker. Our intent of the guard is to keep the employee away from the hazard. So engineering controls, and the last is ventilation, and we'll talk about that in our next slide. Earlier conversations talked about having a laboratory setting where I've got chemicals. If we look at the picture on the left, and what I have is I've got a hood, and I've got a methodology for ventilating and extracting air up and away from the worker who would be standing in front, and the air's flowing past the worker up through the hood and taking whatever the contaminants are away. It doesn't eliminate the hazard because the chemical's still in the work environment, but our engineering control reduces the exposures to that person. On the right, I've got some type of a chemical that potentially not only has toxicity for air, but it may have skin sensitivity, some type of an irritant. So what I've done now is I have gloves that I'm putting on. God, I wish I had my pointer. That I put my hands in, so now I'm protecting my arms. It's enclosed, so it's more than likely ventilated, so I'm taking any the toxic fumes or vapors away. So I engineer, I don't eliminate the hazard, but I engineer and mitigate the hazard down. Administrative controls, standard operating procedures. When I look at my clients, one of the things we look for across the globe is having a work process so that everybody is following the same process when they're in the work environment. It provides the greatest amount of safety by following those particular steps. Written policies and procedures, your safety program. One of my favorite terms I will use in the next presentation, consistent. The reason I have standard operating procedures, the reason I have a safety program is to create consistency across my organization in how we operate. I can't talk about personal protective equipment for long because we've got a presentation on it as well. Our last method of control, we didn't eliminate it. We couldn't engineer it out. We go down the list. The last thing that I have to do, because the hazard is still in the work environment and the level of exposure, as Bob talked about, is still significant that employees could be injured from it. Now I have to start doing personal protective equipment. Goggles, face shields for eye protection, gloves, apron, coats, hard hats for skin, respirators, earmuffs or ear plugs for hearing. There's a variety of personal protective equipment out there that will provide a level of safety. Again, it has not eliminated the hazard, but it provides protection for the worker, even though we were unable to find ways to mitigate that risk in the workplace. I'm going to pass that because I know I got PPE coming up. Here's some examples. The only thing I'm going to say is the middle one is a dust mask that's only good more than likely for relatively large particulates. It typically has a relatively short life and it has limited efficacy. Not the best. The one on the left, and that's the only other one I'll talk about, again, depending on what it is, it's got a canister on each side or a filter on each side that has a lifespan. If you're involved with the safety program, one of the things you need to think about is that those have to be replaced on some frequency. The respirator, after a year, and that's way too long, those things are no longer operable, and now I'm exposing my worker. So understanding when you're buying this type of equipment, what the limitations are and what I need to do to maintain it. On the best practice side, I want to talk about conducting risk assessments. I think it's a cornerstone and it's in, I think, my third presentation. It's a cornerstone of your safety and health program. Maintaining safety data sheets, that's in my next presentation. Employee training so that employees understand why they're doing something and how to do it appropriately. Reviewing your accident records to look for where I have problems in the plant that I may have unfortunately not identified correctly. What are my outcomes? I obviously increase operational safety, and my workers are healthy, or healthier, which is one of the things that any organization wants to have happen. And the last, which has become so much more important in this universe in the last 20 to 30 years, is I improve the image of my organization. I'm not the environmental side, but by being on the environmental side of the universe and helping create a better environment for everyone inside the plant, I'm creating a process that will, at the end of the day, have that healthier workforce. I improve the image of my organization. I want to do business with a multinational. At that point, there's a much higher likelihood that's going to happen because I have a great environmental record, and for my side, I've got a great safety record. Continuing on, so a little more on the micro level, purchase only chemicals in the amounts that are required. Try to keep inventories to a minimum. Store what's immediately used, what's immediately needed, and store the rest based upon what your safety data sheets tell you. And again, we'll talk about safety data sheets in the next session. Minimize your movement and delivery and transfer of those chemicals. Make certain we eliminate waste. That's the environmental side. Develop those standard operating procedures for the handling, storage, and transportation. And lastly, have a process in place for a spill response. Industrial hygiene, so my second to last topic. Bob talked about dose and measurement. One of the things that has to happen from a safety side, very specifically, is we need to understand in the work environment what levels of contaminant are we exposing our workers to. The industrial hygienist is the person that will do that for us. Oops. Their job is twofold. First, they're in their own way, they're doing their risk assessment and doing environmental analysis. It does the identification. They assess contaminants through measurement, what the potential chemical, biological, physical, and ergonomic hazards are. Many of the industrial hygienists do ergonomics, where ergonomics is about lifting and body motion and our muscles and so forth. And then lastly, which is just as important, they've conducted their analysis, they've also will recommend what we can do to minimize those hazards. So my industrial hygienist comes in, tests the environment with their equipment, and comes back with a report that says, for these chemicals, we are in a safe range. Our workers are exposed to them, but at a low enough rate that it's acceptable. For these subset of those chemicals, we're overexposed. And they'll go back to the hierarchy of control and figure out what do we need to do from the hierarchy of control, from elimination down to personal protective equipment. But what do we need to do? And they'll recommend what can be done to mitigate those exposures to chemicals so that we don't have a potential injury. Hazard communication in the U.S., and that's where most of my experience comes from, really is really how do I communicate chemical hazards to my workers? The evaluation, the risk assessment has been done by the chemical manufacturer and importers. I'll talk about that in the next session. You need to have your safety data sheets, which will talk very specifically about each chemical that you're using in the facility. And then you need to be able to communicate that information to the workers, have standard operating procedures that ensure, again, that we have consistency in our work practices and that the employees we've mitigated the potential for an injury. And this is just an example. I'm going to talk about these in the next presentation, but I need to have a labeling system so again my employees have an ability to easily and visually identify what the potential hazards are of a given chemical. 5 minutes? Oh, we're good. I won't go through this slide in the case of 5 minutes, but this is what an employee has a right to be informed, to be trained, and to be provided with the proper tools, PPE if necessary, and they should be able to, at the end of the day, as the safety program matures, every worker in the facility should have enough knowledge to be able to understand and identify the hazard that they're going to face in the work environment. The last part I want to talk about with my last 4 minutes is hazardous materials response. No matter how well we've constructed our standard operating procedures, no matter how well we have limited the transportation of chemicals within the facility, the truth is people make mistakes, errors occur. That happens to all of us. And unfortunately, when it happens with the handling of chemicals, we have the potential for a spill, an uncontrolled release of chemicals that can, whatever our industrial hygienist has told us about how good the universe is in our plant, now it no longer is because I don't have that controlled scenario. I've had a spill and I've got chemicals within the plant. I like to see my emergency response plans look at 2 different scenarios, the most likely. And by that, I want a scenario so that my response team knows what is the highest likelihood thing that's going to happen and what we need to be prepared for. But equally, I have to concern myself with the worst case. Because as much as we don't want it to happen, there's a potential that we could have a significant and a catastrophic release of chemicals. What do I need from my emergency response team? And I want to talk about a few in particular. Obviously, I want all of my employees, but I will tell you very specifically, my emergency response team needs to understand what the exposures and hazards are to chemicals in the facility. Assuming that they're going to potentially fight a fire, which would be one of your scenarios, they need to understand the various types of fire extinguishers. Some are acceptable for certain chemicals, some will not be. So they need to know which type of a fire extinguisher to use given the type of chemicals that are involved in that fire. They need to know first aid potentially, or you need to have people who can do that. They need to understand what PPE they will use, not the typical hourly worker doing the job, because now we have an uncontrolled release. So their PPE, their personal protective equipment they're going to use, may have to be significantly better, for lack of a term, than what we would use on a day-to-day basis. Last thing is they need to understand how to shut processes down, because if they're there and whatever release is occurring, they can't stop. They need to understand what the process is for shutting down part of that particular facility. Your spill control procedures, which is a basic for them. In the event that this is a catastrophic loss, what process will I go through for search and rescue? In big facilities, that unfortunately and typically will fall on your emergency response team. It's something one has to think about. The other thing that I thought was on there, maybe I missed it on the last page, and I don't want to forget this, for my emergency response team, the last thing I'll say is I need one thing for them to do. They need to be able to understand when the spill scenario is outside of their skill set. And now I need to call somebody else in. But what I don't want to do is endanger the lives of my emergency responders by putting them into something where their PPE won't work, or they're not they don't have the equipment or the training to handle a particular situation. So they need to know when to say no. And by that I mean, no, we can't go forward and control this. We need to get a third party, the fire department, whoever it happens to be. Worker safety in the chemical universe. Any questions? All right, then. Thank you very much.
Now I will ask you questions. So, first let me ask the question, then you can. Okay. So far I talked to girls. Let me talk to boys and ask the question. Okay. Tell me how many presentations we had since we started. Please stand. 3. Can you name them, one of them? Okay, sit down. Again, I want you to be aware of what is being spoken, what is presented. I'm not asking questions to embarrass you, but I'm asking questions to make sure that you are attentive and take something home from here. Okay, next.
Thank you for the informative session, sir. Next, I request Kini Gard ma'am to introduce the next speaker, Lois Grandel, to the audience.
Lois has over 30 years of operations leadership experience in manufacturing, global sourcing, and project management. She has led multiple facilities in both unionized and non-unionized environments. She is an experienced sourcing leader in multiple industries, aviation, and industrial heating. Lois has extensive experience in the global supply chain. As a lean leader, she designed the manufacturing layout for a plant in Romania as chief manufacturing engineer. She solved quality and production issues at a plant in France. As executive sourcing leader, she worked with suppliers in Asia, Europe, Canada, Mexico, and majority of the 50 states in the US. As the executive leader of the composites commodity from 2010 to 13, she led a global team based on the UK and US that required a significant increase in the global supply base capacity and capability due to the rapid growth. At Chromalox, Lois oversaw purchasing, quality, safety, and customer service while directing plant operations in the US, Mexico, and China. She defined the strategy to boost operational capacity while minimizing supply chain challenges. Prior to Chromalox, Lois was the president of Rupert Corporation, where she has transformed the plant to increase output by 60% and grew her team to adapt to the changing environment. Under her leadership, the plant earned Best of the Best in North Georgia 2 years in a row and the BBB Torch Award for Business Ethics in 2021. Lois has moved 7 times throughout her career, starting in upstate NY and currently in Ringgold, GA. She holds a BS in Industrial Engineering from Alfred University. Lois and her husband have a son who is currently a senior at the Ohio State University. Thank you.
Can you all hear me? All right. That was really long. Every now and then I'm like, I did not do all that. Really excited to be here and talk to you today about personal protective equipment. And so today,
Let me make sure I get my buttons right. Here we go. Okay, good. So Steve did a very good introduction of personal protective equipment, and he did half my presentation, so that was wonderful. So this is old hat now, okay? So personal protective equipment must be provided when hazards are encountered. And it's not a substitute for all the engineering, the hierarchy of controls that he talked about. First thing we want to do is eliminate the hazard, always. Okay, if we have a hazardous chemical, I don't want anybody coming anywhere near that. Next, can I substitute it with something else that's not as hazardous? You know, we talked about using cyanide for extracting gold. You know, I don't want anybody anywhere near cyanide. That's just very, very hazardous. So is there something else that we could do? And sometimes that involves tremendous amount of research and development and trying to figure out what else could we do. Okay? The importance of the PPE is to create a barrier between the person and the hazard. So some of you were not here when I first started talking earlier today. I told everyone that I'm not a pretty face. I expect some participation from you all, because I don't need to do all the talking. And so what's the ultimate PPE that we could put people in? What do you think? Yes? Yes, yeah, put them in a bunny suit, or put them in a full body suit, right? Cover, they look like an astronaut, right? But is that realistic for us to work, right? I can't walk when I'm in a bunny suit, right? Or it's very hot, and I'm just gonna sweat, and that may cause another hazard. I might have a heat stroke, right? And so we wanna minimize the PPE for what the hazard is, okay? All right. And it always must be in good working condition and correctly worn to provide protection, and we'll talk a little bit more about that. Every single associate needs their own set of PPE. I can't tell you how many factories I've been into, and I'm like, well, where's this person's safety glasses? Well, this person was using them at the time, and there's one pair of safety glasses for 2 people. I said, no, they each have to have their own pair. And it needs to be their own pair. They're not going to share it with somebody else on second shift, right? So they have to have their own pair. The PPE needs to be safe. It can't cause a hazard unto its own, right? It's sanitary and reliable. We've all been through COVID. Once again, we're not going to share safety glasses with someone else because there might be a virus on that now. That needs to be that own person's. And it must meet ANSI standards, the American National Standards Institute. Everybody familiar with ANSI? No? Nobody knows ANSI? If you look at your safety glasses, you'll have an ANSI standards stamped on your safety glasses. And I'm not going to forget that it begins with a Z. But it says that they meet the standards for ANSI. All your PPE has to meet the standards. You can't just go on to Amazon. Do you guys have Amazon here? Okay. Can't just go on Amazon and say, hey, I need a pair of safety glasses. You need to make sure it meets the right standards for what you're trying to protect. Okay? Sometimes you need goggles. Safety glasses are not going to do it, right? It depends on the hazard and what you got going on. And just as Steve said, when you're doing spill planning, you're going to have a much bigger risk of that hazard. It could be in big quantities, whatever that might be. And so your spills response team may need that bunny suit, right? Okay. All right, we talked about the permissible exposure limit, how to properly put it on, take it off, adjust it, and what are the limitations of PPE, and what is the proper care, maintenance, and useful life. And these are all things that everybody needs to understand. So if I'm going to tell somebody that I need you to wear a respirator when you're doing this job, there's quite a bit of training that happens when you tell someone they have to wear a respirator. You can't just hand it to them and say, hey, wear this, okay? What's the number one thing you can't have when you're wearing a respirator? Anybody know? It's for the guys. It's for the guys. What do guys have? Anybody want to tell me? A beard? Yes. Can you have a beard when you're wearing a respirator? Absolutely not. Absolutely not. It will leak out. Whatever the contaminant is will leak out through your hairs. All right? So you have to be clean shaven. All right. Routes of entry, once again, Steve it's a great straight man. You did a very good job. Thank you so much. So inhalation, ingestion, absorption, and injection. I'm not going to go through this. He did a very good job describing all of these. But once again, if it's inhalation, so you're probably going to want some sort of mask to prevent the inhalation. Ingestion, what are we doing to make sure that we don't have food on the factory floor or in the lab so that we don't accidentally touch something, which would be fine. But then if I put my hand in my mouth or I put my hand around a naan and then eat that, now all of a sudden I've eaten that chemical, which is bad. Absorption, it gets on my hand, goes right directly into my skin, or goes into my eye, goes directly into my bloodstream. And then injection, you accidentally poke yourself. So sometimes you need PPE that the needle won't go through. Okay? Medical fields, they use a lot of that. Okay, types. All right, I'm going to go through each one of these. And once again, I'm not going to spend a tremendous amount of time. But eyeglasses are a very, very common thing. And eye protection, and it can't just be eyeglasses. Several of you in here have eyeglasses. Is that sufficient for safety glasses? All right, I warned you guys. I'm not just going to sit here and talk. So I'm just going to start calling people out. All right? So are eyeglasses enough for safety glasses? No, thank you. It is not. Why not? Why not? What do eyeglasses have that safety glasses don't? They have side shields, right? They have side shields, and they also have very special glass that's, if you had a piece of metal from a machine run into your face, it will not shatter, okay? Safety glass, your eyeglasses sometimes are made of glass, and if something came at you, it's going to shatter, and then that will cause an even bigger issue, right? So, side shields, and they have to meet the ANSI standard. They have to be stamped with that Z number. Z87, there it is. All right? And then if we're talking chemicals, sometimes we need goggles, sometimes you need a whole face shield, sometimes you need something that covers your whole body. Okay? So once again, it's understanding the risk and what am I trying to protect. Okay? This is such a simple thing. I've had so many people have stories, and thank God it's never been on my watch. But I've had so many people tell stories where they've lost an eye because they were not wearing their safety glasses. And they were like, oh, I'm just on break. Or, oh, this isn't that bad. And they take their glasses off, and then something flew through their eye, and they lost an eye. Okay? It's such a simple thing to wear, and it's the very basics. Respiratory equipment, we talked a little bit about this already. Lots of organizations, NIOSH and MSHA, there's tremendous amount of regulations around these, and anybody that's wearing a respirator, tremendous amount of training for that employee to understand what they're doing and how they're protecting themselves. They have to be fitted correctly. And so that makes sure that it fits them correctly and you don't have any gaps. And so that, if you're going to need respiratory equipment, that's a big deal. Once again, you want to try and eliminate the hazard so you don't have to wear this. This is, I never want to do this. And then 2 different types of respirators, air purifying and the whole scuba outfit. And now we're starting to look like an astronaut, okay? And there's your level A, level B, level C, level D, different types of respiratory protection. Okay? What are your firefighters usually wearing? Firefighters? You're level A, right? Got a whole suit. Okay. Head protection. When would I need head protection? Name an industry where you wear hard hats on a regular basis. Construction. Yes. Good. Good. Now, can you wear just any old hard hat you get off of Amazon? Yes? You guys are very quiet. It's the afternoon. You gotta wake up. All right? What are the different types of hard hats? What do you have to protect against? In a construction site, what might you be protecting against? Huh? Nuts? Maybe screws falling down from height? Maybe somebody dropped their hammer? Right? So you have to make sure that hard hat could protect someone if a hammer fell from a height. Okay? Or maybe I'm just a maintenance person and I'm clumsy and I bump my head against the pole when I'm under a machine trying to fix something. That's a very different hard hat. Okay? And then there's electrical hazards, different, there's your hammer and splashes and drips. So, I mean, there's many, many different hazards. Once again, you need to understand what the hazard is and make sure you have the right protection. Okay. Electrical shock, maybe what your electrician in the construction site, right? Not only do they need to protect overhead sites, but they need to make sure that if they were to have a shock, the hard hat doesn't add into that, right? And it prevents that. Foot protection. Very commonly, we have steel toe shoes. In my last factory, we all had to wear steel toe shoes to protect the toes. That's very common. But sometimes if you have a lot of liquid, you need to have like rubber shoes or you need to have special soles so you're not slipping. And then there's your ASTM code that it needs to meet. Okay? Hand and skin protection. There's just so many suits that you can wear for full body, and then you go into gloves and understanding what are some of the different types of gloves that you need, and then what are some of the other actual injuries. Ergonomics, everybody know what ergonomics means? Anybody that doesn't know what ergonomics is? Okay. I'm going to assume nobody knows what ergonomics is because nobody raised their hand. Who knows what ergonomics is? You don't count. Up front? Who knows what ergonomics is? I think we need to have some coffee after this. All right, repetitive motion, right? I'm hammering something. Anybody sew? Do you ladies sew? You know, sometimes you're doing a lot of stitching. It could be repetitive, and all of a sudden you're like, oh, my wrist hurts. Okay? So repetitive motion. And there are special gloves that you can wear that can help you prevent some of those injuries. Okay? And there are hundreds of different kinds of gloves and clothing you can wear. So once again, understanding what's the hazard, what am I trying to protect, and try and have the least amount of protection so that that person doesn't have to wear this big, huge glove and they're trying to do delicate work and they can't do that delicate work because the glove's in the way. Okay? So keep that in mind. Hearing protection. You have the muffs. You have the earplugs. Earplugs, very common. Anybody like rock and roll? You ever go to a rock and roll concert? Anybody? Yes, I'm here. I'm saying yes. Rock and roll. What kind of group have you been to? Huh? You like rock and roll? What kind of group? Do you wear earplugs at the rock and roll concert? Yeah. Do you think you should wear earplugs at a rock and roll concert? How many decibels do you think a rock and roll concert is? That's a lot. I would highly recommend everybody that goes to a rock and roll concert wear earplugs. That's mom and me. Because you're protecting your ears, all right? Because it is really, really loud. Okay, care, very important. That is there to protect you. Let's just go back to our basic safety glasses that everybody should be wearing in a manufacturing environment. If your safety glasses have a damaged lens, they're dirty, you can't see through them, they get foggy. If it's humid outside and you go into a colder environment and they all fog up, that's not helping anybody, okay? So make sure they're in good working order. Always inspect them before you use them. Make sure you have a place to store your PPE. You know, as a leader, we talked about you're all leaders, right? As a leader, you need to make sure that the employee has an area to store that PPE, okay? Make sure your hands and face are clean, that you've cleaned yourself before you go eat. There always needs to be wash facilities after you've been working, no matter where you are, like a lab. You need to make sure you wash your hands before you go eat, because you don't know exactly what you had on your hands. And this is, we've been talking about several times, it's your responsibility to help everybody make sure they're using the right stuff. And okay, one more question, and I'll leave you alone. All right? Are you guys ready? You ready to answer this question? You ready? That's very quiet. Okay, one more question. All right, so whose responsibility is it to ensure the employees are protected? Yes, the organization, the management. And might be some of you, right? Right? So you can't sign a waiver, the employee can't sign a waiver and say that, I'm okay, I don't need to wear safety glasses. Now you as the management and the leaders need to make sure that they're wearing what they need to wear. Okay? That's what we were just talking about. All right? So, last resort, we're going to do personal protective equipment. We're going to make sure that that personal protective equipment is the absolute right piece for what the hazard is, to protect that employee and make sure they can continue to be a very productive employee for you going forward. Okay? And then in your work, your papers there, I had a few links for you to go get more information. Lots and lots of information out there on this. Okay? Thank you very much.
Okay, quickly, who can tell me the title of this presentation? Please stand, that way I know who it is. Yes. Wonderful, wonderful. Can I go one step further or is that enough? I can go one step further? Okay. Tell me something about personal protective equipment. General. I don't want to be very specific. Anything? Are you all awake? Oh, you are not eligible. You are faculty. Students. Anyone? Oh my God. Lawyers, you are in trouble. Okay. Well, since I don't get any answer from any of you, I assume that you didn't understand. Can I do that? It is bad. I cannot do that. I know you understood, but you are shy. Any one of you say a little more about protective equipment? Yeah, go ahead. You are the only person that's available now.
There are types of PPEs that has been used. For example, for protection of respiratory thing and for the ears and for the head as well.
That's good. That is very good. So she represents all of you. Do you agree? Because none of you stood up. She stood up for both the questions. So thank you. Please.
I thank Mrs. Lois Grandin for our informative session. Next, I will request Stephen Bennett, sir, to continue the second session.
Hello? Oh, there we go. Good. All right. I told you I was going to be back up for one more session today. My second one is going to be about safety data sheets and GHS, which is global harmonization system. Excuse me for mispronouncing. The agenda is we're going to talk about GHS. We'll talk about safety data sheets, labeling requirements, some pictograms, and ultimately the transportation of hazardous materials. One thing that's certain is that no matter what environment you're in, if it's an office, if it's retail, if it's manufacturing, if it's a chemical plant, or if it's a storage facility, there is a chemical exposure in every one of those environments. What's important about chemical safety, we need to know the name of the chemical, the nature of the hazards, and keep hearing noise, and how to protect ourselves and others is what our goal is with chemical safety from an employee perspective. Something that I learned, although I was working at that particular time, I'm a little concerned about it, but GHS was initially, it was initiated, I think is a better term to use, in 1992 by the United Nations. And the intent, and it's a word that you'll hear me use multiple times, was to create a consistent format that allowed us to communicate information about the hazards of chemicals. So what GHS did is it created regulations related to labeling, about safety data sheets, and the transportation of hazardous materials. and I've kind of walked through those already. It creates consistency in it so that we can easily understand what the hazards are. My one story for you, and again, because of my age, I remember the days when there were material safety data sheets. And I can remember the first time I walked into a gray iron foundry, and my client goes, "We don't know what's going on. We don't know what all the chemicals we used." So they took me to where they had their MSDS books. There were over 300 chemicals. And material safety data sheets, I'm going to say on average, were about 16 pages. Some shorter, some much longer. Information could be anywhere in those 16 pages. So I won't do the math for you, but 300 times 16 and having no idea where the information is. It made for a very difficult process of helping my client understand what the chemical hazards are in their work environment. And so what GHS did is it condensed everything into 16 very specific sections. So information about the ecological potentials of that particular product are in one section. Medical procedures in the event that first aid procedures are in a particular section. It made life much easier for us in terms of finding data. And it provided, my favorite term for the day, consistent information about all of these various chemicals. If we look at the sections, and I'm not going to spend a ton of time, section 1 is identification. So it basically gave the information about the manufacturer, their address, phone numbers, anything you want to know about that specific organization. 2, which was one of, from my side of the business, one of the sections I always looked at was the hazards. What are the physical and health hazards of that particular chemical? What pictograms would be used, what the signal words, and I'm going to come back and do some definition for us on that. What hazard statements and what precautionary statements. So it provided a ton of information about what the health risk would be from that particular chemical. So I can go to an SDS, I can go to section 2, and very quickly have at least an overview of what's going on with that particular chemical. The composition, and quite often, because sometimes they're proprietary, you won't get all the information you want, but there, in some cases, you'll know very specifically what, if it's like it's a compound or a mixture, you'll know all the various chemicals inside in that component. I talked about first aid, section 4, section 5. When I look at my emergency response team, what kind of firefighting measures do I need to undertake? If there's an accidental release, what type of information do I need to know in terms of the size, not the size, but the type of release that's taken place and what kind of measures I need to do to protect my employees and the general public. Handling and storage, particularly thinking about some chemicals are not compatible. Bob talked about that earlier. I need to make certain that certain chemicals are stored in different places so I don't create the potential for a problem. This section will talk about what type of segregation might be necessary. What was talked about PELs, permissible exposure limits, the recommended PPE, and if there are engineering controls, sometimes what you'll see is they'll talk about you need to use this under a vented hood, so that you'll know very specifically some of the engineering controls that should be applied to reduce that exposure to the workforce. Physical and chemical properties. My friends on the scientific side, they're interested in that. I'm just saying, for me, that's not my skill sets. Section 9 was not one that I worried about often. Stability and reactivity, toxicology information. Bob talked about that. In terms of the ecological information, section 12, How do we dispose of what, if I have a component of it left or the waste that comes from it, how do I properly dispose of that? What's the method of transporting and what type of labeling I might need to put on that? Regulatory information, and then finally, administrative. But what I will tell you, for me, on the SDS, one of the things I love to be able to see is my last revision date. Because there are times when my clients will have a safety data sheet that's 10 or 12 years old. And the problem you've got is that as the other speakers have been talking, regulations change, scientific knowledge changes, and the safety data sheet changes. So, a good practice is every 3 years, at a minimum, but every 3 years you ought to be recycling and updating your safety data sheets to make certain that I have the most up to date. And if you are of a sophisticated or mature program, all of these are online and you don't have to worry about that. But if you're in a paper system, you need to make certain on a regular basis you're updating those. Labeling. Again, these are generic comments. Any specific country could do something somewhat differently. All containers must be labeled except the portable containers that are used on a daily basis. Brandon talked about it, but a best practice is to label every container. But if you look at GHS, or if you look at it in the US standards, if it's a daily supply only, it doesn't have to be labeled, unfortunately. And piping systems, again, don't have to be labeled by GHS, but it is a best practice because I don't want to have an accident, an impact. A fork truck, a powered industrial truck impacts a piping system, and I have no idea what's coming out at that point in time. The labeling requirements are the responsibility of the manufacturer and the importer. So as a user, the good thing is they're supposed to provide me with the information that's going to allow me to educate my staff to make certain I have the right labels on a particular product. Oh, and the last, we don't see this much anymore. I'll tell you this last one, but I would tell you the first 5 years that GHS occurred in the US, we had a number of very mature safety programs that used, and very specifically NFPA. And so they had a placard system that they would apply on containers that was based upon NFPA. And what I ended up seeing, again, they allowed them to continue. Most people transitioned. So over the course of about 5 years, they would have GHS symbols on there. They'd have NFPA symbols on there. But over time, as employees became used to and understood the GHS labels, the NFPA labels went to the side, and I would tell you, I'm not certain it's 100% of the facilities that I go to anymore. Okay. I'll let that one go. All right. The pictograms, and I'm going to put each of these up on a screen next. GHS has specific pictograms so that you create a visual impression of the various hazards that could be with that particular chemical. Toxicity, the top one are carcinogens, super bad stuff like that, and then the bottom one, Bob talked about the term acute, but acute toxicity, the skull and crossbones has been used, unfortunately, for a long time as an indicator. Again, both of those are indicators that whatever is in that container is highly hazardous to an employee. The exclamation point really is more about irritants. These two symbols, the top would be those that are flammable and self-reactive, and Bob talked about a number of the different chemicals in that, and the bottom symbol is for oxidizers. Compressed gases, explosives, organic peroxides, corrosives. We talked in PPE about the corrosive side, where I have an environmental issue with a particular chemical. So those series of labels will be placed on the containers so that we have some ideas in terms of what the issue is. It is really, if you're just looking at the pictogram, it's really just an invitation to do more research, because it's not going to give you, when you go up to the container, it's going to give you the label information is going to provide you with this data here: the name, address, signal words, and I'll talk about those in a second, a hazard statement, and precautions it should be. What you will see, and here's an example of what a label would look like. And again, on this, and I'll show you, my next one, show you, they don't necessarily have to be in a particular order, but the chemical name, the hazard statement, precautions, the manufacturer's information, the pictograms, and a signal word for this particular product. And it's just a kind of a different look, but the same concept. And here you can probably see the precautionary statements, where they again very specifically talk about first aid, and depending upon whether it was skin, eyes, or inhalation, and then in the event of a fire. So the label that goes on the hazardous materials will provide you with significant information before you go to the safety data sheet. It will provide you with some high-level information about what that chemical is. General guidance on GHS. I talked about the word danger is going to appear if the chemical meets the highest risk in a health-related hazard. If it goes to any of the lower ones, it's going to be warning. So you're going to, and again, if you're on the manufacturing side and you're receiving the chemical, you don't have to worry about defining that. It's the actual manufacturer of the chemical or the distributor that has to go through this process. And for physical hazards, similar process they go through. Depending upon how significant the hazard is, they put danger or they put the word warning on there. In transportation, we use a different set of symbols. In most cases, there's a color that ties into it so that we have I think it assists in the visual observation of what type of a hazard we're exposed to. And again, just with classes, class 1's explosive, class 2's the compressed gases, flammables, class 4's flammable solids, so it goes from solid red to that striping in red and white, oxidizers, poisons, radioactive material, corrosives, and then when Bob wants those lithium batteries, they have to put them under that miscellaneous symbol down there. When we placard a vehicle, the placard goes on really on all four sides, is what this is really telling us: the front, each side, and the back. In the event that there's multiple hazard symbols, and there may be, by the way, the one that will have the number on it, so flammable was class 3, will be the primary hazard. So if I had 4 symbols on a truck, an 18-wheeler, the one that has the pictogram and then a number on it would be your primary hazard. The remainder are, I won't call subsidiary, they're not ancillary, but subsidiary hazards. I know that India continues to move toward adopting GHS. That has not happened yet, but so many countries has, and it is becoming very, very quickly a global standard. And I think one day you'll have it here as well. If you're doing business, if you are on the manufacturing side of a chemical and you're going to send it to the U.S., then that company will comply with this standard, because when you send that chemical to the U.S., it's going to have labeling on it and a safety data sheet, just as I talked about earlier. There are some differences, but for the most part, it's remarkably consistent. And that's the good thing about GHS. It has created a system that creates a high level of consistency in the communication of the hazard information. And they didn't come out, so I took less than my time, which was perfect. Any questions? All right, now comes the question from the boss.
Okay, no questions. Only recognition. Oh, okay.
Sir. Okay, the question is, we have seen some pictograms. Inside the pictograms, we saw some numbers 2, 3 and all. What does it indicate? That is my doubt, sir.
Stephen, please come back to the stage. She has a question.
My snack, what are you doing?
No break.
What's the question?
What's the question?
The question is that we have seen some pictograms. Inside that we saw some numbers 3, 2 and all.
Yes.
What does it exactly indicate?
Well, the number is only an indicator of symbols. So this is a whole other part of the discussion. This is about behavior management. So I am used to being able, with that headset, to be able to talk and not have this in front of me. So I'm over here babbling away as I hold this microphone down. Now I'm where I'm supposed to be. Excuse me for that. Let's go back. The pictograms have a number on it. In the particular, that's just about the class. So flammables, I think, are class 3. That 3 is just telling you that it's just reinforcing that that's the class of that particular hazard. If there were 3 pictograms on it on that 18-wheeler, right? One of them will only have the number on it. The other 2 will not. The one that has a number, and again, that number is just reinforcing that it's flammable. So it's a 3 on the flammable symbol. That tells you that it's the primary hazard. It's the one that's most significant. The other 2 are saying these are hazards of that particular chemical, but they're not as, they've decided that the significant one was the flammability, and therefore they put the 3 on there. But the number is only about the class. It's not a rating system in terms of a hierarchy of is it super hazardous or less hazardous.
Thank you, Stephen. Since she is the only person who stood up every time I asked a question, so my friend Richard Phillips wanted to give a little memento to the only individual who came up to answer questions. Keep asking the question, keep answering the question. Okay. Next one, please.
Thank you, Mr. Stephen Bennett, sir. Now I request CSHOD Dr. Marishwari ma'am to introduce about Catherine Werner, who is the next speaker for the session.
Respected dignitaries of the dais and my dear participants, good afternoon and I, Dr. V. Marishwari, Professor and Heads of Computer Science Engineering, AMCEC. First of all, I would like to thank our management for giving this opportunity to introduce eminent resource person, Ms. Catherine Werner. With over 30 years of environmental, health, safety and sustainability experience in Fortune 500 manufacturing and consulting, Catherine owns and serves as a principal of ESG EHS Services LLC. Her company provides resources to business, government and non-profitable sectors to meet hard to achieve environmental, social and governance goals. She started her career in consulting, working for both Allen and Hamilton and Radiant Corp. She developed Superfund policy in support of EPA in Washington DC and conducted EHS audit globally for a variety of commercial and government clients. For the subsequent 23 years, she served in a multiple leadership role for the General Electric in environmental, health and safety, sustainability, quality and operation across several industry sectors including aviation, locomotive and appliance manufacturing and services, supporting employees and business operations. After retiring from GE Appliance, a higher company in 2021, she served as a Vice President of Sustainable Business Operations for Hubs and Associates, one of the largest independent heating, ventilation and air conditioning companies in the southeastern US. She maintained both her certified hazard material manager and certified safety professional credential and is a member of American Society of Heating, Refrigerating and Air Conditioning Engineers. She resides in Louisville, Cleveland with her family. I'd like to invite our resource person to address the gathering. Let's give a big round of applause. Once again, thank you, Olenda.
Thank you so much.
Thank you so much.
Generous introduction. Oh,
Thanks. Okay. All right. Aha! Hey, look at that. Just put a little water right here. This is perfect. Yeah, this is perfect. Am I slideshow? Am I in? Control F8. Ah, look at that. Okay, then we'll go back one. Here we go. Oh no, let's see. Huh. Well, oh, there we go. Look, wait, it changed on the screen. It's changing here, but not on the screen. All right, we'll just relax, stretch your legs a sec. We'll get rolling on some transportation. I do like that Kendra review. I know you love that that keeps coming up. All right, let's see what we have. Thank you. Oh, yes. All right, we are in business. Thank you so much for the warm welcome. I appreciate the introduction. It's great to be with you. What you're going to see are some themes in transportation. Stephen's talked a lot already about a number of critical topics that are also relevant to transportation. Something you may not realize about transportation, the reason I have these papers in my hand, is what you do know about transportation is that it can be complex. Did anybody come on the roads to arrive here today? Anybody? Some people probably just walked across campus. Anybody drive in today? We fortunately, you're fortunate, we did not actually drive ourselves, but we got a ride. You wouldn't want us driving. Daily transportation is a challenge anyway, right? Just getting around. And I want to share a statistic with you from the World Health Organization. And this was published in October 2023, that 1 of every 10 road deaths globally occurs in India. And the United Nations is working very hard with India throughout the country to reduce this number. And so no matter what you're studying in school, I believe that this is a relevant and important point and topic for you and for your family and for our businesses and organizations that operate here. And having reliable corporate health and safety logistics, whether in India or internationally, it's a very complex set of rules. So what I'd like to share with you today is what some of these frameworks are that guide transportation, across the globe, okay? And then what you'll see, did you know that for adult learning, this is adult learning, it takes 6 times often to hear information, to retain it. And so what is good for you all, even though you all have much quicker young minds, so you probably need far fewer than 6 times to hear this information. What you'll see are some themes though. You're going to see again the importance of safety data sheets and documentation and understanding your chemical risks, particularly in transportation. And so you'll start to see some common themes as we go through this information about transporting hazardous materials around the globe. Again, we're going to start with some repetition now. So when Rampur, Dr. Vishwanath, asks your questions at the end, you can start thinking about this now. So everyone will have their hands raised at the end. So we've defined hazardous materials several times here today, right? We've gone through different types of hazards: physical, chemical, biological, radiological. And we've talked a bit about the global impact, whether to water or to air. And you heard in the opening comments about our mission to protect nature as part of all of our jobs. Okay, so here's another lot of words here, but think about this. As you look at this same list, you've seen this list before, right? You've seen this list before. Hazardous materials, also known as dangerous goods in transport, again, very important in order to know how you're allowed to transport them, whether by air, by sea, by road, by rail. You have to know what the hazard is that you have in order to properly package it, in order to safeguard the public, and in order to put it into transport at all. And so, again, we've been through these different categories of classes. In fact, thank you, Stephen, you just went through the different classes from explosives, radioactive materials, corrosives. We've just gone through those definitions. So understanding what you have is really critical to knowing how you're allowed to ship the different items. There are several regulatory frameworks associated with shipping materials. And there are a lot of acronyms here. In many cases, in addition to the international standards, you may also have in-country standards or state-specific standards. We've talked about the globally harmonized system, and we talked about the fact that GHS was first published in 2003. And here we are now in 2024, and the expected adoption was by the end of 2023, and many countries have adopted this. The transitional period ended here, December 2023, for the adoption of GHS, and many are still on that journey, which is good. But what's nice for you all is now you will grow up in industry with a much more standardized process. So you will not have to learn for every country when you're working for large and leading large multinational corporations. You and your teams will be able to learn a standard set of requirements, and that will help you. As you start to think about some of the different frameworks, I'm not going to teach you every element of the frameworks, but I want you to understand some of these acronyms and what some of the major ones are. So if you are working for a multinational corporation that sells into Europe or into the United States, that you will be familiar with some of the most common regulatory frameworks. And should you decide to have your career focused in procurement operations, sourcing, which requires extensive knowledge of transportation rules, whether you're shipping your products out or receiving products in. You will need to know some of these acronyms. Now the French have also done a good job of propagating some requirements. So the ADR is Accord d'Angers Routier. This is the European Agreement concerning dangerous goods over roads. Okay, so transport throughout Europe on roads. And vehicles, again, as Stephen said, have to be properly equipped, labeled, and not different requirements, but it's a little bit of a different acronym and regulatory structure that reinforces the need to follow these rules when you have goods in transport in Europe. Another that is less discussed are rail requirements through Europe. A lot of the railroads go through highly populated areas in Europe, and consequently, the rules are very strict on what and how you have to package dangerous goods for transport. And so that is why it's worth just, again, knowing that this program is there, because as you send goods for transport, think about it. If you're at a if you're at a facility, you can control your perimeter access, and you can control a lot about who has access to your chemicals. But when they go into transport, there are a lot of unknown situations that can come up. Other drivers, whether your driver had a good night's sleep, lots of different factors, right, that can impact the safe transport of dangerous goods. The two most common regulatory frameworks that you'll hear about is around marine shipments, because it's very cost effective to package up materials and send them over the sea, and then they're received by different ports. So the International Maritime Dangerous Goods Code is the most common code and source of regulations for shipping overseas. And IATA, that's the pronunciation of the acronym, is the most common. It is the requirement for air shipment. And there are a lot of restrictions on air shipments. So the International Air Transport Association sets the global standards for the airline industry on what can be shipped in transport. And again, there are several items that we've covered that I wasn't going to recover, such as the labeling, the placarding. Stephen has been over and showed you in quite a bit of detail on some of the labeling and placarding standards that are required for this type of transport. So when you think about international transportation, this is a complex system. I believe, tomorrow, we're going to talk some about emissions and reducing greenhouse gas emissions. And I'm going to come back to this model of emission controls, and we'll talk a little bit more about what are the different ways, not only to reduce emissions, but also cost in transportation with international transport. And a lot can be, you can take a lot of cost out and take a lot of emissions out by thinking about your routes and your closest ports of entry. And I'll share with you some examples of some multinational companies that have saved at least 8 figures annually in their shipping costs by changing their port of entries. And they've also had a significant impact in metric tons of carbon reduced by reducing overground trucking. So we'll talk a little bit more about that when we cover sustainability tomorrow. The focus here is really on making sure when you offer something for transport that you know what it is, you know any hazardous properties it has, and you properly label it and communicate what you have all the way down the line for those receiving that product. Who is responsible for doing that? Anybody know who is in your supply chain responsible for making sure that, I'll give you some choices, making sure that the shipment is properly identified and labeled. So some choices would be, we'll start at the beginning, the organization offering the product for shipment, that's number one, or is it the transporter, the truck who picks it up, the rail, the plane, are they responsible for originally identifying the material and labeling it, or is it the person on the receiving end? Hey, my package is almost here. Am I responsible as the receiver to make sure? Which one do you think? The original, the transporter, or the receiver? I think I heard it. The first one, yes, that's right, that's right. So if you're offering something for transport, it's your responsibility to make sure you've properly characterized that material. Because think about it, we have, just like we just said, a lot of roads and rails particularly go right through densely populated communities. Oh wow, that means you talked too long on the slide. See how that works? All right, we're back, we're back. All right, I'm going old school. Let's see. Well, let me see if I can grab my IT friend again. Are you able to help me out here? Well, I can do it that way. Are you able to? Let's see. Oh yeah, we're back. Thanks. Good. Thank you. Okay, so now that you know who is responsible for making sure that you get it right for what you need to ship, there are lots of things corporations need to do. Training and certification. I just covered a lot of regulatory frameworks. Nobody's expected to know those overnight in one 30-minute class. FedEx, Federal Express, that ships some of the, I think they're still #1 in shipping hazmat globally. Their class that they offer in hazardous materials transportation is probably one of the best I've ever taken, and it's because they found so many packages incorrectly labeled and leaking and causing problems that they have learned a lot of lessons from people mischaracterizing and packing up hazardous materials. And they've also turned those folks over to their various regulatory agencies for enforcement action. So that's the other way that they make sure you don't have repeat issues. But consequently, if you ever have a chance to take a FedEx class for transportation, it's excellent. It's well done. But corporations have to properly train the people responsible for this job. If you're ever walking through a shipping department, somebody says, hey, do you mind, can you just sign here? And you've not had training, just say no. Say, no, thank you, can't do that. Because that makes you responsible, which is fine if you're trained, but it's not fine if you're not. So investment in safety equipment is very important to make sure you obviously have the right equipment. Incident reporting and transparency. If you do have a spill, in many cases you're obligated to report that spill and make sure it's properly cleaned up. It just depends on what it is and how much was spilled and where it was spilled. Was it spilled outside? There are a number of rules around that. And you would need to know, again, back to what chemicals you have, what amounts you have, and what those reporting obligations are. Community engagement, in many cases, with large amounts of chemical stored at a site, you might have to alert the community. In some cases, even transportation requires you to alert a community that certain dangerous shipments of goods might be coming through the community, and certain precautions may need to be taken. Oftentimes, too, there's continuous monitoring on, for example, rail cars, just to make sure all of the protections continue to be in place for highly hazardous chemicals that are in transport. Again, we covered the globally harmonized system requirements. That's very common. UN, United Nations numbering system, also a standardized system. I really agree with Stephen that the more consistency we can have in the process, the easier it is for all of us globally to follow, and the easier it is for a multinational company to have consistent approaches in their transport. So, since you've just gone through in detail, Stephen, the GHS labeling, this is another, what's nice about this is in this package, this is a quick reference sheet for those pictograms that you went through. And I've also included a couple of links that give you some additional information on packing groups and hazards. Right here, this link in this presentation gives you extensive additional information. So when you're in here, you can click here and you can find a wealth of knowledge about some additional details. I will touch specifically on packing groups, though. Should any of you decide to take the CHMM exam, there will likely be a question on packing groups. And I found this to be fairly consistent. So you will get this question right if you study this slide. And you can see packing group 1 indicates the highest level of danger, packing group 2 medium, packing group 3 minor. And if you remember which one is the most hazardous, you will get this question correct. It's I am not going to go through all of the markings that show the different types of containers. But what you need to know is that for each type of material, whether a liquid or a solid, whether corrosive or neutral, each of these materials requires specific packaging in commerce and for storage. And all of the packages, whether cardboard box or steel drum, have very specific markings, typically UL markings, and they will be very clear on what type of packaging you need for each type of material. And you can see, even without me going through, right, it's very specific. And all of these markings also indicate that the packaging itself has been properly tested to be able to withstand dropping the package from certain heights, to make sure that it has the right integrity to stand up to some of the challenges with shipping and handling. So once, to get a package in transport, you have to load it and unload it properly, typically from a dock. A truck will back up, your materials will be loaded, and then eventually a truck will arrive at a location and you have to unload. And this is a time that accidents can happen. The trucks need to be properly docked and secure in order to move the materials in and out of the facility. Fork trucks need to have the correct attachments to be able to properly, and the right load rating in order to move packages properly and safely around a facility. I've included on the slide quite a bit of detail on proper loading and unloading procedures. You'll be probably happy to know I'm not going to read the slide to you, but there's some things that you want to note here. Some we've talked about. Personnel training is critical. If your fork truck driver does not know how to stack, for example, pallets with drums and do some of these things properly, it can really result in some difficult things. You know, we think of transport across the roads and across public roads, and then there's transport within a facility. And transport within a facility equally requires training and consistency in how it's done to prevent incidents. And also, I know we're going to talk about storage. That is, there's a lot to learn there that just leads straight in from transportation to how these materials are then stored. We've talked quite a bit already about essential documentation with safety data sheets, shipping manifests, placards, labels. So again, repetition, now you know, placards, labels. Security planning and risk assessment. We don't want anybody to steal your hazardous materials while they're in transport. So having security and understanding your manifest and how many containers you've sent out and confirming that that same number of containers is received on the receiving end is very important. Not only because money is going to trade hands on, you're going to pay for a certain number of containers delivered, but also for security. If you do have a spill, we've talked about this, you have to be trained to respond to it. And many people are trained to respond up to a certain level. Like I'm trained to clean up a puddle here, but I'm not trained to clean up, you know, say 20,000 gallons that empty out, you know, in a public space. Vehicle requirements and maintenance, that's very important. Who you choose as your shipper is a critical decision for a business. Your low-cost provider may not be your best provider. Back to your public image and brand identity, making sure you have a reputable shipping entity is extremely important to make sure that your products arrive safely. I've talked a little bit earlier about sustainability. I did include just a couple of facts here for you, that a commercial diesel truck can emit 1.2 pounds of carbon dioxide per mile. Based on the assumption that a gallon of diesel fuel produces 2.68 kilograms of carbon dioxide, you can conclude that the average fuel efficiency for a large diesel truck, we'll call it, is almost 3.5 kilometers, per liter, is that, yeah. And the reason this is important, these numbers, is back to the ports, and we'll talk about this a little bit more when we get to sustainability. But again, it also comes back to miles driven is also fuel purchased for transport, and depending on where you are in the world, that fuel is very expensive, and that's a lot of carbon if you're running a diesel truck. As of April 2023, transportation accounts for approximately 14 to 16% of global greenhouse gases. And so again, it's just a fact and a data point for you to consider. We've talked quite a bit about communication. And this is what I wanted to close with here, is this real-life case study that happened in the U.S. A very well-known Class 1 freight railroad company, great reputation in the U.S., had a major derailment in Ohio. 38 rail cars derailed. Thankfully, no one was injured, but over about 12 kilometers of different streams, over 40,000 fish were killed during the process. about a 1 mile radius, 1.6 kilometer radius around the site had to be evacuated. Every person living anywhere in that area had to leave their house for a while due to a couple cars that were burning and generating phosgene gas, plus some other things. And when you start thinking about the profit, I don't know if you can see these newspaper headlines down here, but I'll read them to you. Norfolk Southern's fourth quarter profit falls 33%. 33% as the Ohio derailment costs continue to escalate. These incidents, when we talk about hazardous materials, these are real. And they have severe impacts to people's lives where they happen, as well as to corporate profits as well. Ohio train wreck strains Norfolk Southern. Now there will be job cuts. These are real headlines just from the newspaper when I looked it up. So again, these incidents can have far-reaching implications, and it's the reason to take these things seriously. You may not have ever considered a job in transportation, but experts in logistics and transportation do very well in business because it's a complex area, and if you understand it, it's a great area to know. So just what's interesting here, so you see the date on this, 8:55 p.m., February 3rd, 2023 was when this incident happened. And if you look over here at this little black box, on 2:30 a.m., January 6, 2005, there was an incident in South Carolina that led to, it was much worse. It was a much worse outcome, up to and including 9 deaths, 250 injuries caused by an improperly set railroad switch that caused one train to collide with another. So these both happen to be rail incidents that I'm describing to you. I worked in the locomotive industry for about 6.5 years, and I can assure you that the locomotive industry takes this very seriously. There's a lot of training and consistent practices, but even with that, incidents can still happen, and you knowing about these prevention methods can help us prevent incidents like that. So thank you.
Thank you every delegates for dedicating your time to this beautiful session. It's now time for a refreshing tea break. Tomorrow's session starts at 9:30. I request everyone to assemble by 9 a.m. Attendance is compulsory for the certificate. Once again, thank you all for making today's event successful.